Now that we know the trig functions of our special angles, 30 degrees, 45 degrees, and 60 degrees, we will use that knowledge to find the trig functions of angles that have reference angles equal to 30 degrees, 45 degrees, and 60 degrees. We'll begin by defining a reference angle. This definition will be a reference angle for the angle theta, and we're assuming that theta is in standard position. A reference angle for an angle theta is the positive acute angle made by the terminal side of the angle theta and the x-axis. Now, what do we mean by acute angle? That's an angle that measures between 0 degrees and 90 degrees. Now we'll look at some different angles whose terminal sides are in each of the 4 quadrants, and we'll figure out how to find the reference angle for these angles. Now, notice as we begin that we're talking about angles theta in standard position between 0 degrees and 360 degrees. So, of course, those would be positive angles. So, here's my first quadrant angle, initial side, terminal side. Now, by definition, its reference angle is the positive angle between the terminal side and the x-axis. So in this case, that angle is just this angle right here, isn't it? Now I call the reference angle theta with the subscript r to stand for reference. And in this case, how does the reference angle compare to theta? Well, they're equal, aren't they? So for a first quadrant angle, the reference angle is just equal to whatever the first quadrant angle is. Now, to denote that it's an angle whose terminal side is in the first quadrant, I write as a subscript a little Roman numeral 1 standing for quadrant 1. As an example, a first quadrant angle that equals 55 degrees, and we'll pretend like that this angle equals 55 degrees, well then its reference angle also equals 55 degrees. So obviously that's the easiest quadrant to find a reference angle for. Let's do something more challenging. Let's look at your second quadrant. Initial side, terminal side in second quadrant. There's my positive angle theta. I know that because the arc is in a counterclockwise direction. I'll label this theta so you can see that a little better, and I'll call this subscript Roman numeral 2 because its terminal side is in the second quadrant. Now, for this angle, the reference angle, the measure of the angle between the terminal side and the x-axis, the negative x-axis is the closest x-axis, and we always go to the closest. So this angle would represent my reference angle. Now to find it, because I know it's 180 degrees all the way here, if I knew the measure of my second quadrant angle, what I would do to find my reference angle is I would say 180 degrees minus whatever my second quadrant angle was. So for example, suppose that I knew that this angle measured 130 degrees. To find its reference angle, I would say 180 degrees minus 130 degrees, and I would find that its reference angle is 50 degrees. Let's look at my example of a third quadrant positive angle, and there's its initial side, terminal side in the third quadrant. I'm going to label this theta and then Roman numeral 3. Now, for my reference angle, it's the positive angle between the terminal side and the closest x-axis. In this case, the closest x-axis is the negative x-axis. Positive means that it has to go in a counterclockwise direction. So my reference angle would be the measure of this angle right here. When I get ready to find it, I will use the fact that a straight angle measures 180 degrees. I know the measure of my third quadrant angle, so to find this reference angle, I will take my third quadrant angle and I will subtract from it 180 degrees. Now let's just suppose that my third quadrant angle here measures, let's see, maybe we'll say it measures 240 degrees. To find its reference angle, I will say 240 degrees, subtract 180 degrees, and I will get that this angle measures 60 degrees. Now let's look at our fourth quadrant angle. Initial side, terminal side. There's our counterclockwise rotation. Let's label this theta and then an IV subscript for meaning that the terminal side is fourth quadrant. Now where is the reference angle for a fourth quadrant angle? Its closest x-axis is the positive x-axis, so we want to know the measure of the angle from this terminal side to this positive x-axis. That is our reference angle. We'll use the fact that we know that if we rotate all the way around, that's 360 degrees. So if we want to find this reference angle, we'll say 360 degrees, subtract the measure of our fourth quadrant angle. So let's see, we'll make this fourth quadrant angle, we'll pretend like that maybe it measures 290 degrees. So if we want to find its reference angle, we'll say 360 degrees minus that fourth quadrant angle, which is 290 degrees, and we will find that the reference angle measures 70 degrees. That would be that angle right there. Now, let's review what we just did. For a first quadrant angle, the reference angle equals the first quadrant angle. If we know the second quadrant angle, to find its reference angle, we say 180 degrees minus the second quadrant angle. In the third quadrant, to find the reference angle, we take the angle that's in the third quadrant and we subtract from it 180 degrees. And looking for the reference angle of a fourth quadrant angle, we say 360 degrees minus the measure of the fourth quadrant angle. Let's work some problems. Before we do, just remember, and this is a mistake that some of my students make, a reference angle is always found with reference to the x-axis. Okay. Find the reference angle for each of the following. Well, number 1 is 312 degrees. Now, you may want to draw a little sketch here. 312 is a fourth quadrant angle. So we know that that measures 312 degrees. This is our reference angle. And remember to find the reference angle for a fourth quadrant angle. We say 360 degrees minus our fourth quadrant angle. Did you get 48 degrees for the reference angle? How about number 2? It's 85 degrees. What we want to do is figure out what quadrant its terminal side is in. Let's sketch it. It's almost 90, isn't it? So there's our 85-degree angle. And what do we know about the reference angle for first quadrant angles? Well, it just equals the first quadrant angle. Let's look at number 3, 213 degrees. Let's sketch it. What quadrant is its terminal side in? Well, we know 180. It'd be right on down here, wouldn't it? So its terminal side is in the third quadrant. To find its reference angle then, we will take the angle 213 degrees and we will subtract from it 180 degrees. And when we do that, we get 33 degrees for the reference angle. The last one we'll look at is 154 degrees. If we draw a sketch, we know 90 will be somewhere in that second quadrant because it's between 90 and 180. Since it's second quadrant, how do we find its reference angle? We say 180 degrees minus 154 degrees. When you subtracted, did you get 26 degrees? Now what we're going to do is to combine what we know about reference angles and what we know about the measures of special angles and the trig functions of the special angles to find the trig functions of angles that have reference angles equal to 30 degrees, 45 degrees, and 60 degrees. Here's what I'd like for us to start with. Let's remember what the sine of 30 degrees is. 1/2. What the cosine of 30 degrees is. Square root of 3 divided by 2. And what the tangent of 30 degrees is. Square root of 3 divided by 3. I hope that you've spent time and that you know those. Now, I'm just going to put this aside And we will come back to this later. What I want us to do is to take the angle 150 degrees and let's find the 6 trig functions of 150 degrees. All right, well, here's what I have here. First of all, initial side, terminal side, and this angle measures 150 degrees. And so what we're going to do here is to find the sine of 150 degrees, the cosine, the tangent, the cosecant, the secant, and the cotangent. And what I want to do is first get its reference angle. So we're talking about this angle right here. And we know that to find the reference angle of a second quadrant angle, we say 180 degrees minus the second quadrant angle. And in this case, we find that the reference angle is 30 degrees. Now, what I'm going to do first is to find the trig functions of 150 degrees in a long way so that you will understand what I'm doing. But when I get finished, I'm going to relate that to the trig functions of its reference angle, 30 degrees, and I want you to learn the short way to find the trig functions of any angle that has a reference angle of 30, 45, or 60 degrees. So let's develop this information on the 150 degree angle. All right, here's what I'm going to do. I'm going to construct a right triangle. And I'll denote that it's a right triangle. I'm going to figure out what the x and y coordinates are of the point on the terminal side here, because I know that if I know a point on the terminal side of an angle, I can figure out what r is equal to, and I can get its 6 trig functions. And so that's exactly what I'm going to do here. I'm going to start off by letting the r distance for this triangle, which is the hypotenuse, equal to 2. And because I know that in a 30, 60, 90, and don't I know if this angle's 30 in a right triangle, this angle has to be 60? And I know in a 30, 60, 90 right triangle, if I know the hypotenuse, the side opposite of the 30 degree angle is half the hypotenuse. So what do I know this length is? I know that that length is 1, don't I? And I know that the side opposite the 60 degree angle has to be the square root of 3 times the side that's opposite the 30 degree angle. So if I'm talking about the side of this right triangle, its length is the square root of 3. But if I'm talking about what the x coordinate is of this point up here, what's the x coordinate? If this distance is the square root of 3, because I'm on the negative x-axis, the x coordinate has to equal to minus the square root of 3. And what's the y coordinate of this point right here? Well, in this case, this is a positive one. So the coordinates of this point would be negative square root of 3, 1, and I already know what r is. So for 150 degrees, one of the points on its terminal side would have an x coordinate of minus the square root of 3, a y-coordinate of 1, and r would equal 2. Now, if I want to find the sine of 150 degrees, I know that the sine function equals the y-coordinate divided by the r-coordinate, and so in this case, that would be 1 over 2, or 1/2. To find the cosine of 150 degrees, that's the x divided by r. In this case, that would be minus the square root of 3 divided by 2. Now, we would prefer to put the minus out in front. For the tangent of 150 degrees, I know that that is y divided by x, so that would be y divided by minus the square root of 3, and we know we don't leave that like that, do we? When we rationalize, we multiply by the square root of 3 over the square root of 3, and we'll get this tangent to equal, now this time I'm going to say positive divided by negative, put the negative out in front. In the numerator, I'll have the square root of 3. In the denominator, square root of 3 times the square root of 3 is 3. Now, let's find the cosecant, and I will use my knowledge of reciprocal relationships. If the sine is 1/2, since the cosecant is the reciprocal, it equals 2. To find the secant of 150 degrees, since it's the reciprocal of the cosine, I'll put my minus out in front. I'll have 2 divided by the square root of 3. And of course, I know when I rationalize, I'll have minus 2 times the square root of 3 divided by 3. And last, for my cotangent of 150 degrees, let's see, I could use this reciprocal, but I think it'd be easier to go back here. What's the reciprocal? First, I knew the tangent was equal to 1 over minus the square root of 3. What would the reciprocal of that be? It would simply be minus the square root of 3. So there are my values. Now, here's what I'd like to do. I would like to record my sine, my cosine, and my tangent. Okay? All right, here's what I want us to do. I want us to go back and look at the trig functions of 30 degrees and compare them to the sine, cosine, and tangent of 150 degrees. Here's my paper. Sine of 30, 1/2. Cosine of 30, square root of 3 over 2. Tangent of 30, square root of 3 over 3. Now, look at the function values for 150. The sines are the same. What's the difference in the cosines? Cosine of 30 is positive, cosine of 150 is negative. And what's the difference in the tangents? Only that the tangent of 30 is positive and the tangent of 150 is negative. Now here's what's important for you to notice. The sine, cosine, and tangent, the absolute value, the number part, for the trig functions of 30 is the same as the trig functions of 150. So if you know the trig functions of the reference angle, then you know the trig functions of 150 if you also know in which quadrants the trig functions are positive and negative. Look, Since 150 was the second quadrant angle, its cosine was negative. Its tangent was negative. Don't we know that the sine of second quadrant angles is positive, that the cosine and tangent is negative? Now I want to show you why the trig functions of 150 equal to the trig functions of 30, except for the fact that the signs are different. Did you notice when I did this that I had this dotted line? Well, guess what the measure of that angle is? That angle measures 30 degrees. And if I construct this right triangle, do you see that these triangles are congruent? If I choose this distance to be 1, to be 2, then this distance would be 1, this would be the square root of 3. And so, on the terminal side of my 30 degrees, I would have the square root of 3, 1, that point. And so, because this triangle is congruent to this triangle, they will have the same trig functions, except for the fact that because this has a negative x, the functions that had x's in them then become negative because the r's and the y's were positive. Now, like I said, when I explained 150, I do not want you to work 150 the way that I worked it. I want us to look at a different problem, and the way that I work this next problem is the way that I want you to work to find the trig functions of any angle that has a reference angle that equals 30 degrees, 45 degrees, or 60 degrees. Okay, let's start with use reference angle methods to find the exact values of the 6 trig functions for each of the following angles. Well, here's what we'll do. We'll take the angle, we'll find the reference angle. So let's do that first. We have to know what quadrant the terminal side of 300 degrees is in. If we need to draw a sketch, $300 would be between 270 and 360, so it's a fourth quadrant angle. So we'll find its reference angle. By saying 360 degrees minus 300 degrees, and the reference angle is 60 degrees. And so since its reference angle is a special angle, since we know the trig functions of 60, here's how we'll find the trig functions of 300. We will think the sine of 300 degrees equals, now, what quadrant is the terminal side of 300 degrees in? It's in the fourth quadrant. What's the SIGN of the sine function for fourth quadrant angles? It's negative, and it will equal minus the sine of the reference angle. And so negative because the sine function's negative for fourth quadrant angles, and now we're supposed to know what the sine of 60 degrees is. It equals the square root of 3 over 2. For the cosine of 300 degrees, the cosine function of fourth quadrant angles is positive, so the cosine of 300 degrees will equal to plus the cosine of 60 degrees, which is 1/2. What about the tangent function for angles whose terminal side is in the fourth quadrant? It's negative. So the tangent of 300 degrees will equal minus the tangent of 60 degrees. So that would be minus, and we know the tangent of 60 is the square root of 3. We'll get the reciprocal functions by using reciprocals. The cosecant of 300 would be the reciprocal of the sine, so that would equal minus 2 divided by the square root of 3. When we rationalize, is 2 times the square root of 3 over 3. For the secant of 300 degrees, that will be the reciprocal of the cosine, which will be 2. And the last one for the cotangent of 300 degrees, that equals the reciprocal of the tangent, so that would be minus 1 divided by the square root of 3, and when we rationalize, that would be minus the square root of 3 divided by 3. All right, let's look at a different problem. We want to find the 6 trig functions for an angle that measures 585 degrees. Well, what we need to do first is find its reference angle, but notice that 585 degrees is not between 0 degrees and 360 degrees. So we will find the angle that's coterminal with 585 degrees between 0 degrees and 360. Remember what coterminal means? It means that they have the same initial side and the same terminal side, and we find coterminal angles by adding multiples of 360, or we can subtract multiples of 360. So in this case, we'll subtract 360. And we get 225 degrees. So since 225 degrees is coterminal with 585 degrees, they will have the same trig functions. Now what we want to do is to find the reference angle for 225 degrees. What quadrant is 225 degrees in? It's in the third quadrant, isn't it? Because it's between 180 degrees and 270. So to find the reference angle for a third quadrant angle, we take the third quadrant angle and subtract 180 degrees, and in this case we get 45 degrees. And since that's one of our special angles, we know the trig functions for 45. So let's begin. Let's find the sine of 585 by stating that it's equal to the sine of 225. Since 225 is a third quadrant angle and the sine function of third quadrant angles is negative, we'll write our negative, and then we know it's equal to the negative of the sine of its reference angle. So we get minus, and we know that the sine of 45 is the square root of 2 divided by 2. For the cosine, we'll say the cosine of 585 equals the, I don't know where that came from, the cosine of 225 degrees. The cosine function of a third quadrant angle is negative, so this will equal to minus the cosine of the reference angle, which would be minus, and the cosine of 45 is square root of 2 over 2. For our tangent, we'll say the tangent of 585 degrees equals the tangent of 225 degrees. The tangent function of third quadrant angles is positive, so this would equal to plus the tangent of 45 degrees. And what's the tangent of 45? It's 1, isn't it? Now let's get the other functions. For cosecant, we'll use the reciprocal of the sine. That would be minus 2 divided by the square root of 2. We'll rationalize. We'll have 2 times the square root of 2. And of course in the denominator, the square root of 2 times the square root of 2 is 2. And we can divide those 2's out, can't we? So that divides to 1, so we're left with minus 1 times the square root of 2 over 1, which is simply the square root of 2. For the secant, we'll use the reciprocal of the cosine, but since we simplified the cosecant all the way out, and we know what this is equal to, we'll just say that's minus the square root of 2. And on our cotangent, that would be the reciprocal of the tangent. Well, the reciprocal of 1 is 1. So there are our 6 trig functions of 585 degrees. I'd like to emphasize that you will be expected to be able to find the trig functions of any angle that has a reference angle of 30 degrees, 45 degrees, or 60 degrees without your calculator. Now, I'd like for us to look at one last problem in this lesson that we would be expected to know without using our calculators. It says, tell whether the statement is true or false. If false, tell why. Well, what I do is I just work it out, and in showing my work, I figure that tells why. I'm supposed to know that the sine of 180 degrees is 0. So I'll put a 0 on the left side, and then I'll figure out if the right side equals 0. Well, I'm supposed to know that the sine of 30 is 1/2, and I'm supposed to know what the sine of 150 is. I'm supposed to know that by knowing its reference angle. Now, we found the sine of 150 earlier, but we can review that. We know that the reference angle of 150 is equal to 30 degrees. Since 150 is a second quadrant angle, we know that the sine function of second quadrant angles is positive, so we're supposed to think that the sine of 150 degrees is the same as the sine of its reference angle, which is 30, and of course, we know that the sine of 30 is 1/2. Let's see, 1/2 plus 1/2 is 1. Does 0 equal 1? I don't think so. So this statement is false. This completes the lesson on finding the trig functions of non-acute angles. If you're finished with the tape, please rewind it. Thank you.